Hello, hello.
Uh,
Can you hear me?
yes,
सुनाई दे रहा है?
yes, sir.
Okay. So tell me, what is your current situation? Matrices and determinants. Is there a problem?
Sir, I had to ask how many properties like there are in matrices.
How many properties there are in matrices?
सर जैसे सर एक क्वेश्चन था एडवांस का
Mm-hmm.
उसमें अ, बहुत सारी मैट्रिसेस गिवन थी और
Mm-hmm.
फिर हमें सम निकालना था पी ए इंटू पी ट्रांसपोज।
Mm-hmm. Okay.
तो उसमें हम सर मल्टीप्लाई तो करेंगे नहीं, तो उसमें क्या प्रॉपर्टीज यूज होती है?
ठीक है, स्पेसिफिक क्वेश्चंस हम लोग बाद में डिस्कस करेंगे, पहले थियरी कवर कर लेंगे और उसके बाद जब सब प्रॉपर्टीज समझ में आ जाएंगी देन वी कैन लुक एट स्पेसिफिक प्रॉपर्टीज और स्पेसिफिक क्वेश्चंस। ठीक है। सो
ओके सर।
ओके, सो विल स्टार्ट फ्रॉम द बिगिनिंग। और मेट्रिसेस का मतलब तो पता ही है क्या है। मेट्रिसेस इज जस्ट एन अरेंजमेंट ऑफ numbers in a column and row form, right? So let's start off with basics of matrices. You know what these terms are: row matrix, column matrix, and all.
यस सर।
So row matrix is basically a simple list of numbers. A row matrix can be written like this: A11, A12, and so on till A1n. Basically, इसमें single row है. Similarly, column matrix can be written like this: A11, A21, A31 till AN1, right?
यस सर।
Sometimes these are also known as row vectors and column vectors. Basically, you can imagine this as an n-dimensional vector with components A11, A12, and so on. Similarly, this also can be thought of as an n-dimensional vector. You understand what I mean by saying n-dimensional?
यस सर।
Okay. Now, what is a square matrix? Square matrix. So basically, the number of rows is equal to number of columns here. Number of rows is equal to number of columns. That becomes a square matrix. And in a square matrix, there are elements which are conjugate of each other. So basically, there will be some element here which will be Aij. Across the diagonal, there will also be an element somewhere here which is Aji, right? So for each element, there is a conjugate element across the diagonal where the row and the column number have been exchanged. समझ में आ रहा है मैं क्या बोल रहा हूँ?
यस सर।
If the number of rows and number of columns is n, then this is known as the square matrix of order n. Of order n. Okay. Then we have the term trace of a matrix. What is trace of a matrix?
सर सम ऑफ डायगोनल प्रिंसिपल डायगोनल एलिमेंट्स।
Right. So trace of a matrix is the sum of the diagonal elements, sum of the principal diagonal. Principal diagonal is the one that starts from A11 and goes towards the other side, right? So trace of a matrix is defined only for a square matrix. It's only defined for a square matrix because if a square matrix nahi hoga, तो you'll not be able to go till the end of this, right? A11, A22, ANN. This is a diagonal. If it was not a square matrix, you will not get a diagonal. You understand what I'm saying?
यस सर।
This is not a proper diagonal. It is technically you cannot go across and rectangular matrix में नहीं हो पाएगा. But in a square matrix you can do that. So you should know properties like basically the definition of trace mathematically you can write it as summation of AII, where I goes from 1 to n, and there are some properties of trace of two matrices. So first property is trace of lambda A will be equal to lambda times trace of A, where lambda is a constant. The reason is obvious. When we multiply by a scalar, every term gets multiplied. So all the diagonal terms become lambda, lambda, and all, right? So this property should be obvious, right?
Yes, sir.
Another property is trace of A plus trace of B is equal to trace of A plus B. But this only works if A and B have the same order so that we can add them properly, right? If you cannot add them, it won't work.
Yes, sir.
Then there is a property that trace of AB is same as trace of BA. This can be verified by actually calculating and seeing what the diagonal elements become. AB, and BA do not need to commute for this property to be true. Do you understand what I'm saying right now?
Yes, sir.
AB does not need to be BA. Still, this property will be true. Okay. You can test it out with a few example matrices. It will work out. Right.
Yes, sir.
Then there is also the idea of a triangular matrix, upper triangular or lower triangular. पता है इसका मतलब?
Yes, sir.
क्या है बताओ? Upper triangular, lower
सर
triangular.
अपर ट्राइंगुलर मतलब जो
Hmm.
नीचे वाले प्रिंसिपल डायग्राम के नीचे वाले एलिमेंट्स वो
Hmm.
जीरो है.
So upper triangular will look like this. For example, you will say 0 here, 0 here, 0 here, and let's say 2, 4, and 5. So this is an upper triangular matrix because anything below the diagonal here is 0, right? So the
Yes,
condition for upper triangular matrix can be written as Aij is 0 if what?
I greater than 0.
If I greater than j, and the reverse condition is true for lower triangular if I less than j. So this one will have the upper elements will be 0, right?
Yes, sir.
Okay. Fine. Now basic matrix addition, you know all the properties like commutative
Yes,
nature,
sir.
it is commutative, it is associative. This property is called associative property. You can group them in any order. It also has an inverse. Basically, you can find a B such that A plus B is the zero matrix, right? B is the additive inverse of A. So the definition of inverse is always written like this. If you are talking about inverse of additive inverse, then you say that for any given matrix A, you can find a matrix B such that A plus B is the zero matrix. So obviously from here, B becomes the minus A matrix. That is the additive inverse, right? Similarly, there is an additive identity. Additive identity is basically for any matrix, you can find another matrix that if you add it, the matrix remains unchanged. So the additive identity will be the zero matrix, right?
Yes.
Zero matrix को add करेंगे तो A ही रहेगा. So this zero matrix is called the additive identity. Similarly, you have cancellation laws in matrix addition. For example, if A plus B is equal to A plus C, that implies that B is equal to C. You can cancel it because technically you're subtracting A from both sides. And you can also do the cancellation law on the other side, the right side also. So the properties of matrix addition are pretty obvious. Everything seems normal, right?
Yes, sir.
Okay. Matrix multiplication. So multiplication can be done in several ways, where one way is multiplication by a scalar. So that is pretty obvious. You know that if A is something, Aij.
Sir, there is some question, not a question, but a property like if A into B is equal to A and B into A is equal to A, sorry, B into A is equal to B, then A and B and are orthogonal.
हाँ तो सब देखेंगे आराम से, अभी इतना हड़बड़ी मत करो। ए इंटू बी इज ऑर्थोगोनल का मतलब पता होगा तो हो जाएगा। क्या तुम क्वेश्चन बोल रहे हो? ए इंटू बी इज इक्वल टू।
A
हम्म
and B into A is equal to B.
हम्म देन ए एंड बी आर ऑर्थोगोनल।
Yes, sir.
व्हाट इज ऑर्थोगोनल मैट्रिक्स?
Sir, A square is equal to A. Sorry, A into A transpose is equal to I.
तो अगर ठीक से पता ही नहीं है मतलब तो कैसे पता होगा, कैसे चलेगा काम? अगर तुमको
Yes.
कंफ्यूजन है डेफिनेशन में तो फिर नहीं बना पाओगे ना क्वेश्चन। ए इंटू ए ट्रांसपोज इज इक्वल टू आई, so we just need to prove that this happens if these two conditions are there, right?
Yes, sir.
Okay, so I will take a transpose on this, ट्रांसपोज हम दिस से लेते हैं, दोनों साइड ट्रांसपोज। ट्रांसपोज लेने का प्रॉपर्टी पता है कैसे होता है? यहाँ पे क्या लिखेंगे? ए ट्रांसपोज बी ट्रांसपोज इज इक्वल टू बी ट्रांसपोज, राइट?
Yes, sir.
ग्रेट। और अब इसको ओके यहाँ पे ए बी इज इक्वल टू ए पता है, और इसमें अगर आई वॉन्ट टू गेट ए एंड ए ट्रांसपोज इन वन ऑर्डर, एक सीक्वेंस में लाना है, राइट? दैट्स व्हाट आई एम ट्राइंग टू डू। तो बी बी ट्रांसपोज इज इक्वल टू बी, और इसको अगर ट्रांसपोज करेंगे तो क्या आएगा? बी ट्रांसपोज ए ट्रांसपोज इज इक्वल टू ए ट्रांसपोज, राइट?
Yes.
फाइन। Okay, so what if I multiply A into B is A transpose, A into B is A. ठीक है, यहाँ पे A ट्रांसपोज से मल्टीप्लाई करते हैं दोनों साइड। A ट्रांसपोज A इज ए बी इज इक्वल टू ए इंटू ए ट्रांसपोज इंटू ए, राइट?
Yes,
एक
sir.
एक रिजल्ट ये है, और हमारे पास है ए ट्रांसपोज बी ट्रांसपोज इज बी ट्रांसपोज, B into A is B. So 1 second. So maybe we should take a determinant here, because we know that if it is an orthogonal matrix, the determinant has to
Sir,
be.
the question was that they are idempotent.
क्वेश्चन ही दूसरा है।
Uh,
आइडेम्पोटेंट मतलब ए स्क्वायर से होता है ना, ए स्क्वायर ए पावर एन इज इक्वल टू ए, राइट?
A square equal to A.
तो वो तो इजी ही है, आइडेम्पोटेंट में कोई इशू नहीं होगा। तुमको बी ए और ए बी को पोस्ट मल्टीप्लाई करेंगे तो क्या आएगा इन दोनों से? This should be equal to BA, right? Correct. So basically, what we are getting is BA square B is equal to BA, right?
Yes.
So basically then we can subtract from both sides. We are getting BA square B minus BA is zero matrix. So we can take B. Actually, okay, we are unnecessarily complicating it. We know AB is equal to A. We can say BA में A के जगह पे A, नहीं यहाँ पे नहीं, A into B. What we have is A plus B is equal to AB plus BA. So A plus B is AB plus BA. Immediately, I'm not getting the trick here, but we can figure it out. It's not a big deal. Like AP is, where did you find the question?
Sir, it is like a property, not a question.
Where is the property? Where have you seen it?
Sir, it was in my module of
What
G.
module? Fit G. Show me where it is written. Take a picture and send it to me.
Sir, I can send you in like it is mentioned somewhere online. I saw it somewhere in my module, but right now I'm seeing it online only.
Why are you seeing random properties right now? Right now, I don't even believe कि property सही है. तुमने पहले तो ऑर्थोगोनल बोला था, फिर उसके बाद बोल रहे हो आइडेम्पोटेंट
मैंने
है.
वो गलत याद था क्वेश्चन थोड़ा.
कहाँ है? दिखाओ कहाँ लिखा हुआ है.
So 1 second.
If AB is equal to A, you can say A square is A into A, and A के जगह पे डाल सकते हैं AB and AB into A. And by associativity of multiplication, this can be written as A into BA. You understand what I'm saying?
Yes, sir.
Because multiplication is associative, we can group it like this also, right? So from here we get A square is equal to AB because BA is the same as B. right?
Yes, sir.
And AB is what? Prove हो रहा है A square is equal to A.
Yes, sir.
So that's the proof. The point is, you start off from here, you use the given relation and you use associativity property. लेकिन तुमको अगर प्रॉपर्टीज ही नहीं पता होगा कोई तो फिर कुछ नहीं हो सकता. That's why I'm mentioning all the properties of addition. Similarly, we'll do all the properties of associativity, distributive property, multiplication के सारे properties. Because this is the type of thing where you have to use it. अगर यहाँ पे रिप्लेस नहीं करोगे ब्रैकेट्स को तो फिर नहीं आएगा फिर.
Yes.
Do you understand what I'm saying?
Yes, sir.
You need to know all the properties in a sequence in a proper way without worrying about questions first. पहले प्रॉपर्टीज क्लियर होने चाहिए, उसके बाद क्वेश्चंस होने लगेंगे. Do you
Okay, sir.
understand? Anyway, we'll continue. Scalar multiplication के properties क्या है? First of all, k times a plus b is same as ka plus kb. Then k1 plus k2 अगर two different scalars हैं multiplied by a matrix A is k1a plus k2a. This is the distributive property. And similarly, you can also do k1, k2a is the same as k1 times k2a, and that is the same thing as k2 times k1a. So these are all normal behaviors, scalar multiplication ke properties. There's nothing weird about them. You can use it like this. Now, if you have multiplying two matrices, first of all, you need to know how to write the product of two matrices in summation form. For example, A is m cross n and B is n cross p, right? Then the product matrix AB has order what? AB has order m cross p, right?
Yes.
So you can write the elements of the product matrix IJ can be given by the sum over, you have to create a dummy variable R. R goes from 1 to n, and you have to say AIR times BRP or BRJ, because we are creating the element IJ here, right? Do you understand what notation I am writing here?
Yes.
AB product matrix का I comma J element, right? IJ element will be created in this way, where one dummy variable you have to make, that is the variable that will vary. So basically this means AI1 B1J plus AI2 B2J and so on till AIN BNJ. Correct?
Yes, sir.
यही प्रोसेस हम लोग करते हैं जब मल्टीप्लिकेशन करते हैं मेट्रिसेस का, बट यू नीड टू बी एबल टू राइट इट लाइक दिस एंड अंडरस्टैंड हाउ दिस समेशन इज वर्किंग, राइट?
Yes.
This gives us the I comma jth element of the product matrix. Okay.
Yes,
Now,
sir.
what are the properties of matrix multiplication? First property is obviously that it need not be commutative. That's a very important property. Second property is that if the product of two matrices is the null matrix, then it does not imply that one of A or B is zero matrix, right? It is not necessary that if the product is zero matrix, one of them has to be zero matrix. And there are many examples where you can show, let's say A is the matrix 1, 1, 2, 2, and B is the matrix minus 1, 1, 1, and minus 1. You can see that the product of these two will be zero. However, individually they are not zero. Do you understand what I'm saying?
Yes, sir.
So this is a very important property. Don't make this mistake that say that one of them has to be zero matrix, right? correct? So if AB is equal to BA, then the matrices are said to be commutative. Matrices are said to commute. Whereas if AB is equal to minus BA, then the matrices are called anti-commutative. Anti-commutative. Okay. Now, one very important property, the property that we used in the previous question, the question that you gave, was the matrix multiplication is associative. So A times B times C is the same as A times BC. This is what we used earlier, if you remember. Right?
Yes, sir.
Okay. Then there is also one important property, which is distributive property. What is distributive property? Tell me.
Sorry, A into B plus C is equal to AB plus AC.
This is equal to AB plus AC. And also you can write it as A plus B times C will be equal to AC plus BC. Right? This is the distributive property. And now after this, we come to some of the special types of matrices and the names of those matrices that you need to remember. All of these properties are clear?
Oh, yes.
Okay. So now some of the special matrices and whose names you need to remember. First of all, before we do that, we'll look at what happens when we do positive integer powers of a matrix. So basically the meaning of A power n is simply the product of A n times, right? Now it follows the following properties of exponentiation. These properties are still valid, just like regular numbers में जैसे valid होता है, right? This property
Yes.
is also valid A power mn, right? Also, you should know that if A and B are square matrices of order n, then or same order, it doesn't matter, it doesn't require them to be order n, of the same order, then and AB is equal to BA, or basically they are commutative also, then A plus B power n can be written as binomial theorem expansion, right? Do you understand what I'm saying?
Oh, yes.
This binomial theorem expansion will only be valid for commutative matrices. Okay. If
Oh,
it is
yes.
not commutative, you cannot group them together, no, all of them. Do you understand?
Yes.
फॉर एग्जाम्पल ए प्लस बी स्क्वायर अगर करते तो उसको ऐसे लिखते और उसको लिखेंगे एक्चुअली ए स्क्वायर प्लस ए बी प्लस बी ए प्लस बी स्क्वायर, राइट? Only if
Yes, sir.
AB is equal to BA can we use the AB is equal to BA, then we can write it like this. This happens only in a special case when it is commutative, right?
Oh,
This is the
yes.
binomial expansion of A plus B whole square. So similarly here also the terms will look like the binomial expansion only if they are commutative matrices, right?
Oh, yes.
Okay, now some special matrices. First one is idempotent, which we saw is true for square matrices where A square is equal to A, that is idempotent. Now here, if A square is equal to A, if you know that it is idempotent, then you can automatically say that from here we can say that A power n is also equal to A, where n is greater than equal to 2, right? For all n.
Yes.
The reason is that always you can write a power n is equal to a power n minus 2 into a square, and this becomes a power n minus 1 because a square is a, right? Correct?
Yes, sir.
So you're proving this general relation that a power n is equal to a power n minus 1, right?
Yes.
Now automatically if you go down, you'll get a cube is equal to a square from here, which is equal to a, right?
Yes.
So all the powers of n greater than equal to 2 are all equal to a. The second thing that you can derive from here is that the determinant of an idempotent matrix is either 0 or 1. The reason is you can take det on both sides here. So det of a square is equal to det of a, and this is basically det of a square is equal to det of a. Because the property of det is that det of a power n is same as det of a power n, right?
Yes.
So basically from here we can reduce that det of a can be 0 or 1. Correct?
Sir.
So that is your idempotent matrix. Then we come to the next type of matrix, which is known as periodic matrix. Periodic matrix. So periodic matrix is basically any square matrix that satisfies a power k plus 1 is equal to a for some positive integer k. Positive integer k. If that is satisfied, then A is called periodic. A is called periodic, and the period is the least value of k for which this condition is true. Period is the smallest value of k for which this is true. Do you understand what I'm saying? So basically, if a square was equal to a, then idempotent matrix A has what period?
One.
So idempotent matrix A has period of 1 because k is equal to 1 and this is the smallest power such that the power of A is same as A, right?
Yes.
Okay, so we have seen idempotent matrix. We have seen periodic matrix. The third one is nilpotent. And what this means is it is nilpotent with order m if a power m is the zero matrix and a power m minus 1 is not equal to zero matrix. So basically, m is the smallest power such that a power m is 0. Power such that a power m is same as 0 matrix. Correct?
Yes.
And that smallest power m is called the order of the nilpotent matrix. Finally, we have involutory matrix.
So what is called
Involutory,
M?
huh?
What is called M?
Involutory.
Sorry, sir, in a nilpotent matrix.
M is called the order nilpotent with order m.
Yes.
Nilpotent matrix with order m. If m is the smallest power where it becomes zero matrix, right? Any power higher than that, it will still be zero matrix, but the smallest power m is called the order of the nilpotent matrix. Notice that there is a slight difference between the definition of order here and the definition of order in idempotent, right?
Yes, sir.
What is the slight difference and why do you think there is that difference? The slight
Sorry.
difference is यहाँ पे a k plus 1 was equal to a, right?
Yes, sir.
And there you were saying that no, for periodic matrix and k was called the order, right? Not for idempotent. I was referring to periodic matrix, right?
Sir.
Now the reason it is called k is called the order is because you have to match it to a, right?
Yes, sir.
You can't really cancel one a, let's say, and say a power k is I, right? Because the definition is supposed to make it periodic. Therefore, you cannot call k as the order here in this equation,
Yes.
right? So here, when you do nilpotent, you have to make it equal to the nil matrix. So there is no issue. That whole number is called the order, right?
Yes, sir.
So notice the difference and you should realize that this definitions are slightly different. The next thing is involutory matrix, and the condition for involutory is a square is equal to I. Then that matrix is known as involutory. And obviously det of A here is plus or minus 1. Because here you will get det of A whole square is equal to 1, right?
Yes, sir.
So these definitions are super important. Knowing what is idempotent, what is periodic matrix, what is nilpotent, and what is involutory. These definitions are important for you to remember. Don't worry about advanced properties right now. The purpose of the whole thing is to not try to mug up a lot. You have to try to mug up the least amount of things. Everything else should become obvious by practice. Do you understand what I'm saying?
Yes.
बहुत सारे प्रॉपर्टीज याद करने से ऐसा कुछ भी गारंटी नहीं है क्वेश्चंस बनेंगे. You should try to remember the minimum stuff and try to get sharp with problem solving instead. So focus on solving problems rather than worrying about what property can I use. Okay.
Yes.
Ultimately, we'll cover all the properties and most of the types of questions also, but you also need to realize that it's not about memorizing properties. It's about doing problems that apply them. Okay.
Yes.
And try to keep memorization to a minimum as much as less as possible. Okay.
Yes.
Then there is the concept of transpose of a matrix. Transpose of a matrix basically takes the Aij element of a matrix and converts it to a new matrix where the same element is at Bji, right?
So I had it out in orthogonal matrix.
We will come to it once we reach
अच्छा.
orthogonal. Just relax for a moment, right?
Yes, sir.
इतना भी हड़बड़ी नहीं है, एक ही दिन में सब चीज नहीं खत्म हो जाएगा, right? A is a matrix of order m cross n. What is A transpose? A transpose basically are the elements here. The AMN will go to a new place called ANM, right? All the elements here will get transposed across the diagonal, correct? And the
Yes.
reverse process will also happen. So that is how you construct the transpose matrix. Now, some important properties of transpose matrix are, first of all, A plus B whole transpose is same as A transpose plus B transpose, right? Then
Yes, sir.
there is product AB whole transpose is same as B transpose multiplied by A transpose. Then we have similarly A transpose is same as A. The second property is very important. It is called the reversal law, where the order of the matrices has been reversed. This is important because this rule basically allows you to generalize for multiple matrices. Like it can actually be generalized like this also: A1, A2, A3, whole transpose. It can be written like this also. Correct?
Yes.
You can extend this property. Also, can extend this property. Also, this similar property is also valid in inverse of a matrix. So if you have AB product and you want to calculate its inverse, it will also be B inverse and A inverse. Correct?
Yes.
Okay. Now, the last thing here is that if there is a scalar K times A whole transpose, that will become K A transpose.
Yes.
Okay. So that is your basic properties of transpose. You don't need any other properties. And then we come to orthogonal matrix. Orthogonal matrices. So the condition for a square matrix to be orthogonal is that A into A transpose is equal to the identity matrix. So from here again, det of a matrix here will be plus minus 1 because of this condition. A into A transpose is I. Correct? If you
Yes,
take
sir.
det on both sides here, it is coming det of A square is equal to 1, which means that det of A will be either 1 or minus 1, right?
Yes.
Now, if you think about it, you should also check this calculation yourself. If A is A1, A2, A3, this is my A, then A transpose will be what? A1, A2, A3, B1, B2, B3. Correct?
Yes, sir.
Now, what happens if I multiply A into A transpose? Let's see what happens. So this is a normal multiplication. There's no smart trick or anything. You just have to multiply it out. You will realize that first term will be this first row into first column. A1 square plus A2 square plus A3 square. Then there are other things A1 B1 plus A2 B2 plus A3 B3. This is the second row, right? This multiplied by this we have done, correct? And the third one would be A1 C1 plus A2 C2 and so on, right? Notice that the middle term here, which is the product of this with this, will again be B1 square plus B2 square plus B3 square,
Yes.
correct? And similarly, C1 square plus C2 square plus C3 square, right?
Yes, sir.
Now, if A into A transpose is I, if this matrix was orthogonal, all of these should vanish, right?
Yes.
So basically, we can say that all of these should vanish and all of these should be 1, correct?
Yes.
So what we see, what we are saying is if A into A transpose is I, then summation of I goes from 1 to 3, AI square is equal to summation of I PI square. Do you understand what I'm saying?
Yes, sir.
I have not written it properly. This is equal to sum of I CI square. And this, all of these are equal to 1, by the way. From the
Yes.
multiplication only we can see that, right? Similarly, summation of I goes from 1 to 3, AI, BI is equal to summation of I goes from 1 to 3, BI, CI. And the final one is this, which is 0. So what we can say is that if it's an orthogonal matrix, then what happens? This sum AI square and this BI square and the CI square. So what happens from here is that you should remember this property for orthogonal, okay? This is like saying that the magnitude of the A vector and the B vector and the C vector are all 1.
Yes, sir.
If you think of A vector as like this, A1, A2, A3, B1, B2, B3, C1, C2, C3. This was my A vector. Then A is orthogonal, means A1 square plus A2 square plus A3 square is 1, right?
Yes.
So this column vector, row vector has magnitude 1. This row vector also has magnitude 1. And this row vector also has magnitude 1, right?
Yes, sir.
So that is a quick way to identify orthogonal matrix. Correct?
Yes.
And notice what is the meaning of the second condition. This condition also has to be true for orthogonal. Notice
Dot
that's the
product.
dot product of these, right? So think of
Yes.
these as 3 vectors. Each vector has to be a unit vector and the dot product of any 2 rows or any 2 columns has to be 0. Right?
Yes.
Dot product of any 2 rows, because we are thinking of it as row vectors, right? Are you
Yes,
understanding what
sir.
I'm saying? So that is a easy way to identify orthogonal matrix. Okay.
Yes.
Then the next few properties that are there for matrices concern symmetric, skew symmetric, adjoint, and inverse. Okay.
Yes.
So we will cover these few properties that are left, and then there is matrix polynomials and Cayley-Hamilton theorem. But obviously, the whole discussion of properties is not enough. We have to do a lot of questions for you to get confidence. Okay. तो
Yes, sir.
प्रॉपर्टीज तो डिस्कस करेंगे ही, बट अल्टीमेटली हम लोग को बहुत क्वेश्चंस करने होंगे. So just do a revision of properties and try out questions. I also have a set of questions that I want to discuss. So next class onward से वही questions करेंगे ज्यादा. Properties quickly finish करके questions पे जाएंगे. ठीक है. और इसके बाद डिटर्मिनेंट्स के भी थोड़ा सा प्रॉपर्टीज आने चाहिए और डिटर्मिनेंट्स का मैनिपुलेशन आना चाहिए अच्छे से, क्योंकि दोनों को यूज करना पड़ता है प्रॉब्लम्स में साथ साथ कभी कभी. ठीक है. तो डिटर्मिनेंट्स का भी प्रॉपर्टीज थोड़ा सा देखेंगे. सो बेसिकली द पॉइंट इज वी विल नीड a few more classes to cover the theory with the problems properly. We'll continue from tomorrow. I will let you know the time. Sometime when I'm free, I will do it. And it will take around 5-10 days to finish properly the chapter. Okay.
Yes.
When is your exam?
Sir, 3rd March. Sorry, 3rd April.
That is JEE mains, no?
Yes.
When is advanced?
18th May.
18th May.
Yes.
Okay. So JEE एडवांस का फोकस रख के तैयारी अभी करो. ठीक है. JEE मेंस में तो तुम्हारा 99.38 था ना.
Yes, sir.
So you don't need to worry about JEE mains right now. Focus on advanced for everything. If you prepare for JEE advanced, then automatically JEE mains के लिए रिवीजन तो हो ही जाएगा. ऐसा कुछ नहीं होगा कि खराब हो जाएगा. समझ रहे हो?
Yes.
अभी से फोकस होना चाहिए जेई एडवांस्ड का, उसको टारगेट रख के सारे चैप्टर्स को करो कि जेई एडवांस्ड में क्या आ रहा है, उस टाइप के क्वेश्चंस अटेम्प्ट करो, प्रीवाईक्यूज, ठीक है.
Yes.
So our focus in doing these classes is to finish it at the level of JEE Advanced. It will take 5 to 10 classes to do it properly. We can do daily classes if you want. Tomorrow also we can do a class. Okay.
Yes.
Okay, that's all for now. We'll continue next class.
Thank you, sir.
Hmm.